Alright, in today's lesson we will be exploring how to find the intersection of lines, circles, and parabolas. So, the idea is like this. If we have a circle and maybe we have some sort of a parabola coming through, alright, you can see that the intersections in this case would be like here and here. So for example, we're going to be finding points like these where these two figures meet. Do you have a pencil or a pen in your hand? If so, put it down. Put it down. Watch me do it, learn how to do it, but go back and get the practice yourself by doing it by yourself. Pencil down. Now on problem like number one, really all of these problems, our goal is to get these two equations set equal to each other so we can solve for one variable. In this problem is a little extra easy because see how both equations equal y? If they already both equal y, then we could immediately set these two parts equal to each other. So we could just immediately go x squared plus 5 equals 5x plus 1 and solve it from there. In general though, you have to get everything on one side and set it all equal to 0. So in general, you would have to, for example, subtract x squared from both sides and subtract 5 from both sides. Okay, that way you'd have 0 over here. So the top equation would become y minus x squared minus 5 is equal to 0. And doing the same thing here, if I subtract 5x from both sides, minus 5x, and subtract 1 from both sides, then this is going to give me y minus 5x minus 1 equals 0. So in general, we're going to get both equations equal to 0, so then we'll set them equal to each other. But for this particular problem, this is actually the long way. You'll wind up at the same thing either way. It's just the long way. Okay, now I've set these two equal to each other. Now once you have that, then you're going to start combining like terms, so I would subtract y from both sides and those would cancel out. So right away that gets us close to what we could have done in the first place on this problem. So x squared minus 5 is equal to negative 5x minus 1. I'm going to get everything on the left side. So I'm going to add 5x to both sides and I'm going to add 1 to both sides. Okay, so over here I will have negative x squared plus 5x. Negative 5 plus 1 is negative 4, and that's equal to 0. Now I'd like to factor this, but trying to factor with a negative sign in front is annoying. So I'm going to multiply everything by negative 1. Okay, and I'm going to pick this up over here. So this is going to give me x squared minus 5x plus 4 equals 0. So if you factor this down to get the solution, x squared is x times x. 4 is either 2 times 2 or 4 times 1. Looking at the 5, I'm thinking 4 times 1. Now to get negative 5, I need a negative 4 and a negative 1. Alright, and there I'm thinking inner, I had 4x. Outer, I had 1x. To get negative 5, I need them both to be negative. That's what I was thinking. And then also, a negative times a negative is a positive, so that works out too. Now to get the actual solutions, I need to set these factors equal to 0. Okay, so x minus 4 equals 0, and x minus 1 equals 0. All right, that's going to give us x equals 4, and this is going to give us x equals 1. Okay, now this is not your final answer. These are the x's, but we still need to find the y's that go with them. So I like to think of it as a t-chart, where I have x's over here and y's over here. These are both x's, so I've got my 1 and my 4 x values, but I want to know the y values that go with them. Now, basically I'm going to go back to one of these two equations. The bottom one is easiest. I see y equals 5x plus 1. Let me just write that down. So I know that y equals 5x plus 1. Alright, so here this means that y equals 5 times 1 plus 1. Well, that's just 5 plus 1, so that's 6. And here that would mean y equals 5 times 4 plus 1. 5 times 4 is 20, plus 1 is 21. Alright, so my two solutions should be 1, 6 and 4, 21. Alright, that should be it for problem number 1. By the way, notice, let's look back and ask ourselves what kind of shapes these were. Okay, y equals x squared plus 5. When you just have one variable squared, cover up the 5 for a second. Y equals x squared. You know that that is a parabola. Okay, so we had one of these. And then y equals 5x plus 1. Nothing is squared. It's like y equals mx plus b. So that is a line. So what we just found was the intersection between a parabola and a line. And so these were those 2 points that we just found. All right, let's move on to number 2. All right, let's go ahead and ask ourselves what kinds of shapes we're dealing with here. See how both the x and the y are squared? That's what happens when you're dealing with a circle. So what we have here are two circles. So the idea is we have two circles, perhaps they're intersecting, and we're going to find it's possible that there will be 2 points of intersection. Of course, it might be just one, or it could be no solution. We'll have to find out. Okay, again, the idea would be to set these equal to each other. And so eventually I'm going to get 0 on one side, and so I can set these things equal to each other. I want to give you some advice on a shortcut though, because eventually I'm going to take things like, you see this y minus 3 squared. I'm going to be multiplying this out, like y minus 3 times y minus 3. So that'll be y squared minus 3y minus 3y plus 9, y squared minus 6y plus 9. I'm going to be doing this to all 4 of these things. But I can make my life a little bit easier if I notice ahead of time. Do you see anything that these two equations have in common? A whole term that they both have in common. I'm talking about this. Both equations have an x minus 2 squared in them. So because of that, it will be easier if we cancel these out. Okay? So here's what I mean. Alright, because this will save me from having to multiply these out and deal with it. I'm going to subtract 9 from both sides, and I'm going to subtract 16 from both sides. Okay, so if I do that, now if you'll permit me, that will make this become minus 9 equals 0, and that will make this become minus 16 equals 0. Okay, Now I'm going to go ahead and set these equal to each other now. Okay, so the top one here, I've got x minus 2 squared plus y minus 3 squared minus 9 equals x minus 2 squared plus y plus 4 squared minus 16. All right, now I've got them set equal to each other. So the shortcut is to not multiply these two out because they're the same. I can go ahead and subtract x minus 2 squared from both sides, which means essentially because I have the exact same thing on both sides, they're going to cancel out. Technically I'm doing this, minus x minus 2 squared minus x minus 2 squared, and that's how they're canceling out. But when you see that you have the same thing on both sides of the equation, you can just cancel it out, and you're subtracting mentally. Okay, so the rest of it I'm going to have to actually multiply it out. So understand that y minus 3 squared is y minus 3 times y minus 3, and I've got my minus 9. And here I've got y plus 4 times y plus 4, and I've got my minus 16. If I double distribute this, I'm going to get y squared minus 6y plus 9. Then I've got my minus 9, I just brought that down. If I double distribute this, I'm going to get y squared plus 8y plus 16 minus 16. How convenient. I'm doing this one step in my head, all right, because we've done it so many times. I'm hoping you can just follow me. But let me just say this one time. When I'm talking about this double distributing, I'm doing y times y, that's y squared. When I do y times 4, okay, I'm getting 4y. But then when I do the second one, I immediately have 4 times y, so that's another 4y. So that's the part I'm doing in my head. The outer 4y and the inner 4y together make 8y. So whenever I do this, you're going to just see me do that in my head. And then 4 times 4 is 16. So I just thought I should mention that one time, just in case I have one kid out there going, where is he getting the negative 6y and the 8y from? What is he doing? Now you know. Any hoozle. Notice we have all y's, so we should be able to solve this easily. This is going to work out really nicely because, those cancel out and these cancel out. Okay. Now as I go to get these together, I'm going to subtract y squared from both sides. So these are going to be gone. So that just leaves me negative 6y is equal to 8y. Interesting. So if I were to subtract 8y from both sides, say, to get these y's together, that's going to give me negative 14y is equal to 0. Well, the only way that's going to happen is if y is 0. I guess technically you could think of it as dividing both sides by negative 14. So I'm getting y equals 0, guys. Okay, I'm getting y equals 0 for my only y value, my one and only. So, with that in mind, I need to find the x value that matches it. So I always think of this as a t-chart. So I got x and y, and so far I've got that y is 0. So I need to know what the x value is. Let's see, so what am I going to do? I just need to go back to one of my original equations and plug in 0 for y and see what I get for x. Okay, so just remembering back, I'll use the top one. So I've got this equation, and I'm about to plug in 0 for y. Or I'll switch colors so you can see it better. Okay, so plugging in 0 for y right here is going to give me x minus 2 squared.
Jenny Harp, please call the main office at 123.
Okay, I'm just plugging in 0 for y, and now I have to find x. So this is going to give me x minus 2 squared plus. Now this is just negative 3 squared, so that's 9. Okay, and that's equal to 9. If I subtract 9 from both sides, then I've got x minus 2 squared is equal to 0. Okay, that's fine and dandy. This is x minus 2 times, you know what, let me do it the easy way. The easiest way to deal with this, since it's just the only thing here, would be to take the square root of both sides. Alright, take the square root of both sides. Technically it's plus or minus, but plus or minus 0 is the same thing, so I don't really have to worry about it. So that'll just give me x minus 2 equals 0. Adding 2 to both sides, that gives me x equals 2. Okay, so I got x equals 2. So that means my one and only intersection point is the point 2, 0. Alright, so that is it for problem number 2. And here's a quick glance at what those graphs would look like. So as you can see, it is the situation where the two circles are touching at a single point. They are tangent to each other. And that single intersection is the point 2, 0. Alright, so that's what happened. Alright, well, let's take a look at number 3. Now I kind of want to approach number 3 a little bit differently. See how we already have y equals this, and it's real simple. We are all ready to take this and just substitute it in. Okay, we don't have to do anything else. So there's no need to try to set these equal to each other or something. I'm not sure that would really help anyway. So let's go ahead and just take this y equals and substitute it right in and see what happens. So that's going to give us x squared plus, now here I've got y squared, but instead of putting y squared, I'm going to put this negative 2x in there. Okay, and equals 5. So just do the substitution, I think, is the easiest and best way to go. So now I have all x's, so this is beautiful. So I'm going to keep my x squared. Now if I square this, it's going to give me positive 4x squared. You know, negative times negative is a positive. And that equals 5. So this is like 1x squared plus 4x squared, so that's 5x squared is equal to 5. If I divide these by 5, alright, these 5's will cancel out, so I'm going to have x squared equals 1. Now I'm just going to take the square root of both sides. Please remember that when you take the square root of both sides, the solution is positive or negative. That's two solutions. If you forget that, you're only going to get one solution and you're only going to get half credit. But this is plus or minus 1. Now, so we have our x values, plural. So when I go to do my chart, understand that I've got two x values here. I've got a negative 1 and a positive 1. And I'm looking for the two y values that match it. So, easiest thing to do is use this little equation right here. Y equals negative 2 times x. Didn't really do that the way I wanted to. Anyway, so in this case, that means y equals negative 2 times negative 1. So that's positive 2. And in this case, that means y is equal to negative 2 times 1. And that is negative 2. So our two solutions are negative 1, 2 and 1 comma negative 2. So that is how you do problem number 3. Let's talk about what these are. This bottom one, can you tell that that is a line? It's like y equals mx plus b. Nothing is squared, so we have a line here. And then this one, see how both of them are squared? That means it's a circle. So we're talking about the intersection of a line and a circle, and what we just found were these two intersection points. Okay? Alright, last problem, number 4. Okay, let's definitely do this the easy way and just do a quick substitution. Because y equals x squared, again, I can just take this x squared and substitute it for y right now. So that's going to give me immediately x squared is equal to 2x. Alright, so x squared is equal to 2x. So I just need to solve this. The easiest way to do that is to get everything on one side and factor. So I'll subtract that. So that's going to give me x squared minus 2x is equal to 0. So notice I just have the two terms, okay? So there's a common factor here. It's x. So what you want to do is just factor out that common factor. Just undistribute that x. And that's going to leave behind x minus 2. Think about it. If I did the distributive property, x times x, x squared. X times negative 2, negative 2x. Alright, so you see they are the same. But in this form, I can see I've got two factors. And I need to set them both equal to 0. So here I have x equals 0. And over here, if I do x minus 2 equals 0, adding 2 to both sides gives me x equals 2. Alright, so we have these two x values. Now we need the y values that go with them. So we have x and y. So my x values are 0 and 2. So I could use either one of these. I'm going to use this one, y equals 2x, to find my y values. So this means y equals 2 times 0, which is 0. And this one means y equals 2 times 2. So that's 4. So my two solutions are 0, 0 and 2, 4. Alright, and that's it for number 4. Did I say something about this being the last one? Because if I did, I lied, and I apologize. Y equals x squared. By the way, that's a parabola. Alright, notice only one of them is squared, so you know you got a parabola. And then y equals 2x is a line. Okay, nothing is squared, you know it's a line. So we were finding the intersection of a parabola and a line, and these were the 2 points. Okay, there are 2 more problems before we're done. Okay, these are both already equal to 0. However, we need some of these things to be the same so they will cancel. In fact, it would be great if we could cancel out an entire variable like the y's here. So you know how I could do the distributive property. I'm going to multiply this by negative 2. And what that's going to do is give me a positive 2y right here. So that's going to give me, so this is going to become positive 2x squared, okay, minus 4x, and then I'll have positive 2y, okay, and I will have negative 6 equals 0. Alright, see, watch what happens. Now, if I set these equal to each other, watch what happens. Just cheating a little bit here. Alright, so if I set these equal to each other, then I'm setting this equal to the top one. So I've got my x squared minus 2x plus 2y plus 2. All right, see, I really needed these to cancel. So now that I've got the same thing on both sides, these two y's will totally cancel out. All right, that's important. If nothing cancels out, we kind of have a problem. So now I can finish the rest of the problem by subtracting x squared from both sides. Okay, so I mean, I might as well do this too. So technically we subtracted those from both sides, so they're gone completely. But as I subtract these are gone. I'm going to add 2x to both sides. All right, and I will subtract 2 from both sides. Okay, so now everything's gone from the right. So 2x squared minus 1x squared is just x squared. All right, negative 4x and positive 2x, that's negative 2x. Those are gone. And here, these two make negative 8 equals 0. See how the y's went away? That was important. So we had to multiply this time in order to make those variables cancel out. Think of it as trying to make these terms be exactly the same so that they will cancel out. All right, anyway, now we can go ahead and finish the problem as usual. We will factor this. So this will be x times x. 8 will work as 2 times 4. That means inner we have 2x, outer we have 4x. I need a middle of negative 2. So if I have a negative 4 and a positive 2, that will do it. Also, a positive times a negative is a negative, so that works too. Okay, setting these factors equal to 0. So I have x plus 2 equals 0, and x minus 4 equals 0. So this will give me x equals negative 2, and this will give me x equals 4. I am not finished though. I need to come over here and do my t-chart. So I need x's and y's. So my x's are negative 2 and 4. All right, now I need the y values that go with it. Okay, there's no simple equation I can use, so I'm just going to use the top equation even though it's ugly. So the top equation is, so plugging negative 2 into the top equation. Let me change colors. If I put negative 2 in for x, then what I have is I've got x squared, so that gives me negative 2 squared minus 2 times negative 2, and then plus 2y plus 2 equals 0. So I just plugged the negative 2 in for both of these x's. That's going to give me 4 plus 4 plus 2y plus 2 equals 0. That's going to give me 8 plus 2y. Well, actually, let me just do this all at once. 8 plus 2 is 10, so a total of 10 there. So that's going to give me 2y plus 10 equals 0. Subtracting 10 from both sides, so I have 2y equals negative 10. Dividing by 2 gives me y equals negative 5. Okay, all right, I need to do that one more time with a 4. Okay, I think I'll use purple. So, again, just putting in a 4 here. That'll give me 4 squared minus 2 times 4, and then the rest of it. So, plus 2y plus 2 equals 0. This will be 16 minus 8 plus 2y plus 2 equals 0. Alright, so 16 minus 8 is 8. 8 plus 2 is 10. So that once again gives me 2y plus 10 equals 0. And obviously that's going to end up, it's the same equation we just did. So I'm going to end up with y equals negative 5 just like I did last time. Okay, so that means our two solutions must be negative 2 comma negative 5, and 4 comma negative 5. All right, that was problem number 5. That was a little tough. Okay, last problem. This really is the last problem this time. Number 6. Okay, I have a choice. Well, you know, I don't have a choice. Both of these are already equal to y. So y equals this. Y is already by itself. So I can just take this and just substitute it in for y right now. Okay, I think is the best thing to do. So that's going to give me 1/2 x minus 5 equals x squared plus 2x minus 15. Okay, I know what you're thinking, but Mr. Burton, there's a fraction. Come on, that is ugly. Okay, we can handle that though. What could I multiply by that would get rid of this fraction? That's right, I could multiply by 2. Alright, and I'm allowed to do that as long as I multiply everything by 2. Okay, if I multiply everything by 2, then these are going to cancel. So I will just have x, but then I'll have minus 10, and then 2x squared, and then 4x, and then 30. So I'm just going to get everything over there this time. So minus x from both sides, bam, plus 10 on both sides, ka-bam. So that's going to give me 0 equals 2x squared plus 3x, okay, minus 20. Okay, I need to factor this. There is no GCF, so I'm going to have to deal with that as is. So when I go to factor this, 2x squared can only be 2x times x. Now 20 can either be, it could be 4 times 5, or it could be 2 times 10, or 1 times 20. Alright, I'm going to try the 4 and the 5 first. Now I know the 4 will not go here because that would cause a GCF, common factor. Okay, so instead I will do 5 and 4 like this. I'm going to try it out. Inner, that gives me 5x. Outer, that gives me 8x. I'm trying to get a middle value of positive 3. I can get a positive 3 if I have a positive 8 and a negative 5. Alright, so there's my negative 5. And this will give me positive 8. And a negative times a positive is a negative, so that works out too. Alright, so now I'm just going to set these factors equal to 0. Okay, so 2x minus 5 equals 0, and x plus 4 equals 0. Adding 5 to both sides, that'll give me 2x equals 5. Dividing by 2 gives me x equals 5 over 2. Okay, it's a fraction, but that's okay. Subtracting 4 from both sides gives me x equals negative 4. So these are my two x values. Now I just need the y values to go with them. Okay, so x, y. So my x values are negative 4 and 5 over 2. Okay, let's see. There is a simple y equation I can use. It's 1/2 x minus 5. So let's just use that. So y equals 1/2 x minus 5. Okay, so let's see if I can squeeze this in here. So for this one, that's going to give me y equals 1/2 times negative 4 minus 5. Okay, half of -4. You know what? Let's just put this in a calculator. I mean, I can do it, but a lot of you would make mistakes. Okay. So, in the calculator here, really the best thing to do if I'm going to use a calculator is just use the table function. Let's just do 1/2 x minus 5. So this will be 1/2 x minus 5. Might as well start at -4 since that's what we want first. Alright, so at -4 I've got -7. Okay? I would recommend using the table function. And, oh, you know what? That's not going to work out so well with the x value being a fraction. So I'm just going to go back and plug it in. You know what? Maybe I could tell it to start at 5/2. Let's try that. Table function. Okay. Will it do a fraction right here? Let's see. 5/2. Alright, okay. Yeah, I guess I could have. Yeah, 5/2 is 2.5, so I could just tell it to start at 2.5. Anyway, let's take a look. So at 2.5, we have -3.75. Okay, which by the way, -3.75 as a fraction is -15/4. Okay, so that means our final answer is -4, -7, and 5/2, -15/4. Alright, and of course I could have said this as -4, -7, and I'm making a video. It's alright. And 2.5, -3.75. Alright, I could have said it that way. Alright, either way, that is it for problem number 6. And that was the last problem. Alright, a little challenging, but you can do it.